Alright, today we're going to do section 3.1 and we're going to take a look at parallel lines, skew lines, and some parallel planes, and then we're going to see what happens when we get some transversals and some cool angles with that. So you see I drew this figure on this left. This top black rectangular shaped object is a plane. The one below it is also a plane. So we have these two planes. Then we have these two yellow lines on them. This top one we will call M, and this bottom one we will call N. We'll call the top plane T, the bottom plane U. And then this line, this orange line that's going through intersecting both of these planes, we'll go ahead and call that K. So you probably know what parallel lines are. Those are lines that do not intersect, and they're coplanar. And you probably could put together what a parallel plane is going to be. Those are going to be two planes that do not intersect. But this concept of a skew line is going to be a little bit different. Skew lines are lines that do not intersect. So they're just like parallel lines in the fact that they don't intersect, but they're also not coplanar. And so what that means, if we take a look at this yellow line and we extend this yellow line out indefinitely, and then we have this orange line, that yellow line and that orange line, they will never intersect with one another. And that is because they're in two different planes, right? It's hard to visualize on a 2D surface, but I imagine you can put your arms over top of one another to where they don't intersect, and they never will, but they're not parallel. And so what we would say here is the following. In yellow, I'm going to write that lines M and N are parallel. And the symbol that we use for parallel is two straight lines like that. So M is parallel to N. We would say that lines M and K are skew lines, or are skew. And then finally, we would say that planes T and U are parallel. So T parallel to U. That symbol with the two double lines means is parallel to. And so if we were to do an example of identifying some parallel lines, some skew lines, etc., I'm going to start off by drawing a quick cube. And to draw a cube, we're going to just go like this. We'll go out to here, go straight across, and this is where we get nitpicky. That's okay. We'll come down like there, and we'll go back here. And then just because we want that all to be straight, we'll connect like that. So now we have our cube. These are all going to come down back here. So these dashed lines mean they're behind those solid surfaces. So you would not be able to see those dashed lines. And there is our cube. Now each one of these cubes is going to have a vertex. Like each one of these corners is a vertex. So we got A, B, C, and D here on top. We're going to have E, F, G, and H on the bottom. And then we're going to draw a line that connects A to G. Some interesting things you might want to know is we're going to highlight this line right here, DC. And it also connects at a right angle right there. And then line A also connects, or that vertex A is also right angle, and then this is also right angle down there. Those three right angles are just showing to you that this entire cube is a normal cube. It's all right. And so the first thing I want to do is identify a line or lines parallel to CD, that's why we highlighted CD in red, containing point A. So now we have to look where point A is at. So we're going to highlight that there in orange. And we'll actually, you know what, we'll do that with the highlighter. So there's where point A is. And now we have to find a line that is parallel to it. So we have to remember that parallel means never intersecting. So now in orange, we're going to highlight that right there. So line AB is parallel to CD. We're going to do the same sort of thing here, but now we're going to do a line skew to CD. So that's that red line on the cube over there, and containing point A. A dot with an above a letter, that means point A. And so now, once again, we're going to go back to this orange dot over here, and in pink, we're going to highlight the skew lines. So notice that if we go from A to H, that is never going to intersect with CD. So AH is a skew line to CD. Also, AG is on a completely different plane too. So AG is also going to be skew to CD. Next, let's see if we can find a line perpendicular to CD that contains point A. So perpendicular means that the two lines intersect at a right angle, and those little red squares we put in the corners indicate right angles. So we have point A identified there, highlighted in orange, and if you go to the left towards CD, there is a right angle there. So now if we highlight now in purple, that line AD is going to be perpendicular to CD. And then finally, we're going to take a look at some parallel planes. So we want a plane parallel to EFGH containing point A. And so EFGH, we're going to highlight that in yellow, is this bottom face. And so the face that would be parallel to that is going to be the face that is on top. And so we would say that is plane ABCD. A couple of postulates that might come in handy when working with parallel lines and perpendicular lines is the following. We have postulate 3.1, and this is going to be the parallel postulate. And the parallel postulate is going to say the following. If we take a line L and we have some random point P, so that point right there is P. What the parallel postulate says is that there's only one line, and exactly one line, that can go through point P that will be parallel to L. And if you try to draw any other line that goes through point P that is parallel to L, it will be that orange line. Likewise, postulate 3.2 is a perpendicular postulate. And if we take that same line L, oops, it's a little bold of line L, and we put the same point P here, this states that there's only going to be one line, and exactly one line, that can go through point P that would be perpendicular to L. And I guess I missed the mark there. Gotta come over a little bit. There we go. And that can extend downward, and we will have our right angle there. Some more identifications of parallel and perpendicular lines is in order. So I'm going to draw what kind of looks like a city grid. If you could imagine a city block here. So actually, I need these two lines to be parallel. So I will do a little trick. We'll copy that one, paste that one here. So now those two lines are 100% parallel. And we're going to go ahead and draw a street coming out like that. another street coming out like that. And you can start to see how this would look like a city grid. And now some cities have some weird stuff going on, so this is going to run through there like that. So here is our city grid, and this is the information that is given to you. This line and this line are parallel, and this angle right here is a right angle. We're going to have point A, point B, and then we're going to have C, D, and E, F, and then G, oh, not G, M up there in the corner. First, let's name a set of parallel lines. Well, we are given a set of parallel lines. That's identified with those two red triangles. So those are going to be this line. Oops, that is not what I wanted to do. It's going to be that line. And that line are going to be parallel. So we would say that line DM and lines EF are parallel. So DM is parallel to EF. Next, we want to identify a set of perpendicular lines. And so you can see that right there with this right angle. If we highlight that line in orange and go with this right angle, that means that DM is going to be perpendicular to MB. And that upside down capital T, that means is perpendicular to. And then one final question. Is AC parallel to EF? So we need to identify where AC is at. And so that's going to be this line right there. And then EF is going to be this line around here. Those two lines, if you were to extend it out, would definitely intersect. So no, those two lines are not going to be parallel. Next, I want to do a little thought experiment with you. If you take two lines, and these don't have to be parallel lines, and then run a transversal through them. So a transversal is a line that will intersect two other lines. Notice that there is 8 angles formed. So we got angles 1, 2, 3, and 4, and angles 5, 6, 7, and 8. And these angles have special names. So we got to do a little bit of setup here. We're going to have that same sort of picture that we just saw. Put our arrows on the end, but I don't want the numbers on them. So we're going to go ahead and copy that. I'm going to paste this down there. We're going to come, we got to do this 4 times. So paste it down here and paste it down here. So that's just a little bit of setup for later. I want to first talk about what is called corresponding angles. And corresponding angles are going to be angles that are in corresponding positions. So if we take a look at angle 1 right here, the angle that is in the corresponding position to angle 1 would be angle 5. And this is going off of this chart right there. So we would say that angle 1 and angle 5 are corresponding. Likewise, we could have 2 and 6 would be corresponding. We could have 3 and 7 corresponding. And then finally, we could have 4 and 8. Now, when you go through examples and identify corresponding angles or any of the other angles I'm going to show you, be aware that sometimes the numbers are not in this exact 1, 2, 3, 4, 5, 6, 7, 8 order. So don't just memorize my chart that I give you. Next, let's look at alternate interior angles. And so we need to find an angle that looks like it's on the interior. So that would be like this angle right here. 3 is on the inside. And then alternate means going across, and so across from that would be angle 6. So we would say that angle 3 and angle 6 are alternate interior angles. Likewise, 4 go across the transversal to 5. Those two are going to be alternate interior as well. Well, if we could have alternate interior angles, we can definitely have alternate exterior angles. So if we identify angle 1 right there and go across the transversal on the outside, because we're exterior, that's going to be angle 8 over there. Likewise, if we take angle 2 and go across our transversal, we're going to have angle 7 over there. And then finally, we're going to have what is called consecutive interior angles. So interior means we're going to be on the inside. Consecutive means we're going to be on the same side. So we're going to go 3 down to 5. And then we're going to go ahead and go from 4 down to 6. So these are our different angle types. We have consecutive interior angles, alternate exterior angles, alternate interior angles, and corresponding angles. And our final example, I'm going to draw a set of lines, and we're going to cut those with a transversal. Oops, let's go ahead and do this guy this way. And we're going to go ahead and do this guy this way. And then our transversal is going to be this way. So we're going to take that model that we just had and rotate it 90 degrees. So we have in red here angle 1, 2, 3, and 4, and then angles 5, 6, 7, and 8. And I want to list the corresponding angles, the alternate interior angles, the alternate exterior angles, and then finally we're going to list the consecutive interior angles. So first we'll do our corresponding angles. Those are going to be angles that are in the same corresponding position. So that would be like 1 and 5, or 3 and 7, or 2 and 6, and 4 and 8. So we'll go ahead and list all of those right now. So we got 1 and 5, 3 and 7, we got 2 and 6, and 4 and 8. Next, let's look at the alternate interior angles. So we're going to start on the inside, go across the transversal. So that's going to be like 2 and 7. Or we could do angles 4 and 5. Next, let's take a look at alternate exteriors. So we're going to be on this outside. We're going to go across the transversal. Oops, that's not across the transversal. Go across the transversal to there to 8. So we're going to have angles 1 and 8. Or 3 and 6. Notice that these numbers are different from our previous numbers. So always be mindful that the numbers might not always number up the same, right? Somebody might do something like 1, 2, 3, 4. So always be mindful of the numbers. Finally, let's do consecutive interiors. So we're going to say on the inside, don't cross the transversal inside. So we got angle 2 and 5, and angles 4 and 7. That's all I have for you today, and I'll see you in the next one.